Hey guys, I guess this is section seven of the major design project portfolio. And in this one, we're looking at appropriate research and experimentation of materials, tools, techniques, and design testing and testing of design solutions. Um, I tell you what, you can be a great student, really good at English. You could have smashed every other section, and then you might get to here, and if you don't do this, your whole portfolio and design can go a little bit downhill. So it is really important. It's often maybe 10 pages, maybe even more of your design folio, because you're really trying to show that you have experimented and you have tried to come up with the best possible solutions. So, as per usual, the must haves we've talked about. So, an opening statement. Again, it may not be needed, it may not get you any more marks, but it might just show your teacher, and maybe it'll show the marker that you actually understand where this fits in. So, I think it's pretty important to do about a paragraph explaining why this part of the portfolio is important to your design process. So let's have a look at that. Then we'll have a look at the high level responses. I know I put band six in there. That's just to get you aiming high, but this is just pretty much to get to the top of the mark range in the marking criteria. So outline of the research and testing that you will undertake. It should directly link. I know I said this in video number 2. It needs to directly link to your areas of investigation. So the first thing you can do is just go and grab your areas of investigation, look at that primary and secondary research that you said you were going to do, and you might think of more things. You might go back and modify it, but you're pretty much going to do what you said you're going to do in the areas of investigation section. So you need to evaluate the research, tests, and experiments that you do. And of course, at the end, as we know is important for section 3, we will have some sort of final evaluation. High level responses. Red word is really important. Evaluates and applies. So evaluates and applies. So you're actually doing it now. Like you're going for it. You're trying to make your project and you're applying anything that you've learned to make it the best thing that it can be. It needs to be appropriate research. There's no point just sticking in a whole heap of copy and paste of random secondary research that you found from somewhere and hoping that's going to get you, some extra marks. Really, they're not looking for that. They're looking for you doing relevant research that is appropriate in whatever it might be. So, and that could be, evaluated research, could be a test, could be experiments, and so on. So I'm not going to go over this too much, but you can have a bit of a look if it helps you. What it might be. So I've kind of broken it down into research. So go back and have a look at your research plan. Industry experts, focus groups, surveys, secondary research, seeing what else has been done, looking on the internet and so on. They're sometimes intertwined, but yeah, there's kind of a breakdown of what primary and secondary might be. And again, just my opinion. Maybe it's not exactly that. So a scaffold, what my research area is. Here's the summary of the findings from my research. So I might list in where I got my research from there, what I thought that I got from it, and how I'm going to apply that to the project. So this kind of fits into a later section as well. So you're kind of showing that you're doing it there, your application of the conclusions that you reached from doing the research. So I decided that I was going to test 3 different types of timber, and I found that one particular type of timber was far better than the others. But I did that by researching the properties of those timbers, and then I came up with that idea, just as an example. Experimentation and testing. I think I used to say that you need a fair bit of it. I'm not going to give you a number, but you need to be experimenting and testing in whatever it is that you're doing. A simple way to do it, and again, this is not the only way to do it, and people might disagree with this one, but I like to set it out a bit more like a science experiment, which you guys are probably pretty familiar with. So what's the aim of my experiment? Here's some picture evidence of what I did. Here's the results. This is the conclusion I came up with. Here's the evaluation, sort of what direction it gave me. What did I want to try next after that, if you like? So the HSC markers comments have said the best responses referred to the use of relevant and appropriate testing and created a broad range of model solutions to inform the design development. Yeah, so don't forget about your modeling in here as well. Like if you're doing a product, system, or environment, whatever it might be, and go back to the introductory video if you don't get that. There's going to be models, and we'll have a look at a sample in a minute, and you can probably see some of that develop. Appropriate testing techniques were selected and then applied to the product, system, or environment. These tests, from these tests, the results were analysed. So, what's my conclusion? What am I going to do next? And decisions were made for the further design development for improvement. So, this is standard design practice if you're a real designer. Not saying that you guys are not real designers, but if you were working as a designer, you would go along something along those lines. Let's have a quick look here at our good old skateboard. So research started with a focus group. It's not just your opinion. So you need to talk to different people, talking about the different parts of it. Look at the materials that are most appropriate, the materials that you're thinking might be used. You probably already started to think about it in the areas of investigation. Looked at existing stuff that was used for skateboards in this particular one. Looked at existing materials for timber, what might have been used in skateboards before. Some breakdown of what the properties of that timber were, for example. Steel, actually went to a steel supplier and spoke to them about it. I need to do this, I need to do that. Sometimes someone that's been working in an industry for 20 years, they're going to have way more knowledge than you could find by searching on the internet for 5 hours, and you can get that information out of them in like 10 minutes. So it can be really important. Some research on steels, the property of steels, different types of skateboards and so on. I'm just going pretty quick through that. I'll try and stop just in case you're interested and you want to have a bit of a look. But you can see it's like fairly extensive research that has been done. More from a industry expert, went down to a local skate shop. I'm designing a skateboard. Who should I talk to? Let me talk to a guy who runs a skate shop who's probably been a skater for his whole life. And he will probably give you more information, as I said, in 10 minutes than you might get from 5 hours of researching on the internet. You just need to just do it. People are used to that. Don't ever think that you can't go and talk to someone. They probably want to talk to you, and they're probably interested that you're interested in what they're interested in. If that makes sense. Some of the equipment and skills that might be needed. Geez, it's pretty hard. Every school is different, and some schools have everything and some schools have nothing. So I think I mentioned it in the introductory video. When you're deciding on your project, you kind of need to think about your budget and what you have and what skills you have and what your school has and what skills your teacher has and so on. But in this case, he's listed all the skills and things that he needs, and he's actually looked if he couldn't get it, at school or he didn't know it himself, he's looked at ways that he could potentially get it. Into some primary research. So in this case, he talked to a guy who actually worked in aerospace as a sheet metal worker. So, very valid when you're working with steel. A little bit more on the comments from his industry expert. We began, I know I said this earlier, but hey, you need to know what you got to do. Some people might consider this a waste of a page, but in this page, the student's shown me that he understands what he had to do for the major design project and the portfolio. He obviously understands the breakdown of the different areas, and I think there's probably some marks somewhere in that, or at least it lets you know. Spoke to a past student, so again, he's doing his primary research and learned a little bit about their experience, which is not a bad thing, and into the experimentation and testing. So trying to determine exactly how it would work. I know the student had done some initial testing and things, and some of this he probably doubled up a little bit in this, but he's just showing that he has actually gone through the experimentation and testing phase to try and come up with the best design solution that he probably can. So, again, simple scaffold, different to the one I showed you before, but here's the aim, the materials and equipment, the method for doing it, the testing of the treated pieces, the results, and the conclusion that he came to. So lots of that in there. I'll try and pause on each page just in case you're interested. Trying to bend a bit of timber there. And so on. So we're getting like towards the 60 page mark, so 57 pages by the time he's gone through that. It's leaving him 23 pages to complete the folio, which could have been a bit more succinct. But I would not fault this student so far for what he's done. So looking pretty good. All right, thanks guys. Go check out the original video, the introduction video, to try and let you know the whole process, and that will help you out a little bit. But thanks for watching. Cheers.